Hello students, welcome to eCareerPoint-English YouTube channel. So guys, till date we have studied about the different electronic displacement effect, in which we studied about the inductive effect, resonance effect and mesomeric effect, and today we are going to start with the stability of resonating structure. Okay, so today we are going to start the stability of resonating structure, how we can find out the stability of different chemical species and order. Okay, so guys, this is the one of the most important chapter for your NEET preparation. Clear? I hope you people are safe at home and busy with the preparation of NEET 2021. So guys, if you want any free study materials, guys, download our eCareerPoint app, where you can get the offer of, by applying code of XII, you can get 10% of offer in our eCareerPoint product, and this is valid up to 30th of November. Clear? So guys, today we are going to start with the stability of resonating structure. How we are going to arrange the stability order between different chemical species. Okay, in the previous lecture we have discussed about the resonance, what is resonance, what is the condition of resonance, how the delocalization of electron going to take place. Okay, so today we will start with the what is resonance. We will take have a look on resonance, and after that we will go for the rules. We will go for 5 rules how we can find out the stability order of the chemical species. Okay, so we will start with the what is resonance. Okay, so generally resonance happen whenever there is delocalization or conjugation of electron. Okay, so it is first happen whenever there is delocalization, or simply we can say that a movement or shifting. Okay, means one atom is not attached with another atom, it can further move to one atom to another atom, means electron moves from one atom to another atom. This movement of electron is known as delocalization of electron. So we can say that movement of electron is known as delocalization, or this is also known as conjugation. Clear? So delocalization of pi electron, either pi electron or either lone pair within a structure. This is important. Okay, so delocalization of pi electron or a lone pair within a structure, it means that resonance going to take place. Okay, so you have to remember 2 points. First point is delocalization of electron, and second point you have to remember the delocalization of shifting of electron is going to take place within a structure. Clear? Now this is the first point, and this is known as resonance, condition of resonance. Now whenever there are many structure or form in the condition of resonance, either 2 structure or form, 3, 4 and many structure or form. So these structure are known as resonating structure. These structure are known as resonating structure, or we can say that canonical form, or we can say that canonical form. So whenever there is question is asked, write down the canonical form or resonating structure, both are same thing. Okay, so different structures we have named as resonating structure or canonical form. Clear? So second point is clear for you. Now we will go for third point. All the resonating structure, this is important point of the resonance. All the resonating structure mix together to form a hybrid structure. Actually, during a resonance, 2 structure is formed, which we have covered in the earlier class. One is hybrid structure and second is resonating structure. Okay, so generally different chemical species, they are when the structure is temporary, then the structure is known as resonating structure, and if the structure is permanent, we can say that that is a hybrid structure. Clear? So all resonating structure can mix together to form a hybrid structure and having the same energy. This is the important point. All the resonating structure, any chemical species having the structure having a structure of resonating structure, all having a same energy. Okay, no change of energy going to take place between interconversion of resonating structure. Clear? Now we will draw a resonating structure of one of the species. Okay, so we will draw a resonating structure, so then you can easily connect what is resonance. So we will take an example of carbonate ion. Okay, we will take a example of carbonate ion CO3 minus 2, in which we will draw 3 resonating structure of carbonate ion, and after that we will draw a hybrid structure. Okay, so first CO3 minus 2 structure. In this structure we will first draw a first resonating structure as C. Okay, here is double bond O, here is O, and here is O and minus and minus. This is first resonating structure of carbonate ion, in which one oxygen atom having double bond, one oxygen atom having single bond and having a charge, and after that this oxygen atom having a single bond along with ion, along with charge. Clear? So this is the first resonating structure of carbonate ion. Now we are going to draw another resonating structure by the properties of conjugation, where the delocalization of electron going to take place. Now this is a electron, this is delocalized because here the conjugation going to take place, because here is pi, sigma, and here is single electron. Pi, sigma, single electron. So we can say that there is a shifting of electron due to conjugation, and now this electron will shift to this direction and this pi bond shift to here. Okay, so we will be going to draw a second resonating structure as O minus, because this electron is going with oxygen atom as O minus, and this electron is shifted to here. Okay, so we are going to form a second structure as O, and here is O minus. Okay, again this is the second resonating structure of carbonate ion. C, O minus, double bond O, and here is O minus. Okay, so here the delocalization of this oxygen atom going to take place, oxygen electron going to take place. Now we will move further and we are going to draw another, resonating structure as C. Here is C. Now this electron going this side and this pi bond is shifted to here. Okay, so we are drawing a third resonating structure as O minus. Here is double bond and here is O minus. So we can say that this is the 3 resonating structure of carbonate ion, where the pi bond or the shifting of pi bond going to take place. In the first structure, here the pi electron, now it is shifted to here, and in the third resonating structure it is shifted to here. So we can say that carbonate ion or CO3 minus 2 having a 3 type of resonating structure, and all these three are the resonating structure of carbonate ion. They remain for some time, they are a temporary structure, and after it will converted to what? After it they are converted to they are interchangeable. Okay, so these 3 are the resonating structure of carbonate ion. Okay, now we are going to draw a hybrid structure of carbonate ion as here is C is the central atom, and here is oxygen atom, here is oxygen atom, and here is again a oxygen atom. Okay, this is the main structure of hybrid structure. This is O minus, this is O minus, this is O minus, and we are drawing a double bond. Here double bond shifts from here to here to here, here to here and here. Okay, so the shifting of pi double bond or a pi bond is going to take place in all 3 oxygen atom. So we are going to draw this bond as dotted line. So this is dotted line, and again this is a dotted line. Now this structure is known as a hybrid structure. This structure is known as hybrid structure, and this structure is give the real picture of physical and chemical properties of this carbonate ion. Okay, so one thing you have to remember, that the resonating structure, these resonating structure are, though in this condition resonating structure is going to take place, and we can draw this resonating structure with the help of delocalization of pi electron. Now we are going to start with the different rule. Okay, you have to remember 5 rule, only 5 rule you have to remember, and you can easily find out the stability of different chemical species. Okay, so we are going to start with the rule number 1, and after that we will see all rules in detail. Okay, so you have to remember only and only 5 rules. Okay, now we will go for next slide as the rules for stability of resonating structure. Okay, how we can find out the stability order among different species. Okay, either they are neutral, either they are positive charge, or either they are negative charge. Okay, so we have to find out the stability order. So first is rule number 1. First you have to apply rule number 1, after that 2, along with that you have to apply. Okay, so always you have to give preference to rule number 1. After that we will move as a rule number 2, 3, 4 like that. Okay, so first you are going to preference the rule number 1, and what rule number say that first we have to check the aromaticity and for conjugation in chemical species. Okay, first you have to check the either the compound having a aromatic or having a conjugation properties. Okay, so first you have to check the conjugation property. Okay, either they are having a 5 conjugation properties, which I have already told in the previous lecture of resonance effect. Okay, I have told you the 5 condition of resonance conjugation, 5 properties of conjugation, in which if the conjugation going to take place means they are going to give a resonance effect and they are more stable. Okay, so first you have to check the aromaticity, and for conjugation, if the more the conjugation means more the conjugation, more will be the stability of structure. Higher will be the conjugation and higher will be the stable structure, means that chemical species are stable in nature. Okay, let's take an example of this is the first chemical species, this is a alkene carbocation, and secondly we have to take the example of this. This is a aromatic compound in which C6H5CH2 plus. This is both are the carbocation. Okay. Now, according to our conjugation rule, it consists of double bond, it consists of single bond, it consists of plus bond. So we can say that there is a conjugation of pi, sigma and positive. In this condition, pi, sigma, positive rule is applied and the conjugation going to take place, means this chemical species is stable in nature. Okay, due to conjugation. Now we will move further here. This is the aromatic compound, and again we will apply as here is double bond, so sigma, here is double bond means pi, here is sigma, and this is positive charge. So again the property of sigma, so pi, sigma, positive, pi, sigma, positive, and again this is aromatic compound, pi, sigma, pi, pi, sigma, pi, pi, sigma, pi. Again this ring consists of full of conjugation, and again there is a conjugation more in this this chemical species. So this is chemical species also have a conjugation, and this chemical species also have a conjugation. Now if you have to find out the stability order, if you find out the which one is more stable between this chemical species or this chemical species, so we will go for first aromaticity of that compound. Okay, the compound, this is aromatic and this is more stable due to this benzene ring. Okay, due to this benzene ring, or we can say that this is more stable because here more conjugation going to take place. Aromatic compound are more and more stable as compared to any of the chemical species of organic compound. Okay, so we can say that conjugation here also take place and here also the conjugation take place, but in this chemical species the conjugation going to take place along with aromaticity. So we can say that this compound is more stable as compared to this compound. So we can say that this is second compound and this is first chemical species, so second is more stable than first. Okay, so always first you have to check the aromaticity, and after you have to check the conjugation property in the chemical species. Okay, so this is the rule number 1 of your stability of resonance. Okay, first rule you have to apply first, and after that we will go for rule number 2. Now rule number 2 say that more the number of covalent bond, okay, higher the number of bond, higher will be the stability, or more will be the stability. Clear? So means any of the chemical species having more number of covalent bond or more number of pi bond means they are having a what? They are having a more stable configuration or more stable chemical species. Let's take an example of this is the chemical species as CH3O CH2 plus. Okay, this is the one of the chemical species, we have to first find out the resonating structure of this compound, and after we will find out the what? After that we will find out the which one is more resonance, which one is having a more stable. Okay. Now here oxygen is there. They are having a 2 lone pair. CH3O 2 lone pair, and this is CH2 and this is O plus. Now the condition of lone pair sigma, this is sigma and this is plus. Lone pair sigma and plus. I already told you this is the condition of conjugation. So here the condition of conjugation going to take place. So we can say that here the resonance effect will be effective, and we are drawing another resonating structure as the shifting of lone pair here going to take place. So we are going to draw another resonating structure because here the conjugation is going to take place. So this is CH3, and here this lone pair comes to here. Okay. So we can say that here is O, here is double bond, and here is CH2. Okay. So this is CH3, this lone pair comes here, and this become a CH2 double bond. So CH3 single bond, O double bond, CH2. So this is the second resonating structure of this chemical species. Now we have to find out the stability of these two resonating structure, that which one is more stable. Clear? Now according to this, we have to according to rule number 2, we have to count the number of covalent bond. We have to count the number of covalent bond in the structure. So we can count, this is having 3 CH3 plus 1 plus 1 plus 2. So it is having a 3 and 5, 6, 7. This is having a 7. This is having a 7 covalent bond here. Now we can find out, here is 3 plus 4, 5, 6, 7, 8. Okay. Here the covalent bond, number of covalent bond is more. Here the number of covalent bond is 7. Here the number of covalent bond is 8. And according to rule number 2, more the number of covalent bond, more will be the stability. So we can say that this is first compound and this is second chemical species. So we can say that second is more stable than first. Clear? Second is more stable than first because the second one is having the more number of covalent bond. Okay. In some books it is written as covalent bond as pi bond. You can count number of pi bond. More will the pi bond, more will be the stable, the resonating structure. So here is no pi bond and here is one pi bond. Means this is having a more pi bond, means this chemical species is more stable. Clear? So this is rule number 2. More the chemical, more number of more the covalent bond, more will be the stability. Okay. Or we can say that more number of pi bond means more the stability of that chemical species. Clear? Now we will move to the rule number 3. Okay. Now rule number 3 says that the neutral species means any of the chemical species do not have any charge, either positive charge or negative charge. Means neutral species are more stable. They are more stable as compared to charged species. Okay. So neutral species are more stable due to more stable as compared to charged species. Okay. Now we have taken an example of CH2 double bond, CH single bond, NH2. Okay. This is a neutral species. No charge is here in either of the carbon atom or in nitrogen atom. Or now can we say that this compound or this chemical species going for resonance or giving a resonating effect? Let us see. Here is double bond, means here is pi. Okay. Now here is single bond, means sigma, and here is two lone pair, nitrogen having a 5 electron, valence electron in their outermost shell, or we can say that 1, 2, 3 and 4, 5. So nitrogen having a 1 lone pair in their outermost shell. So we can say that pi sigma lone pair means here the conjugation properties is satisfied. Here the condition of conjugation is satisfied. So we can say that this is chemical species or chemical compound going for conjugation or giving a resonating structure. Okay. Now we are going to draw a resonating structure of this compound as here. What going to take place? This electron comes here and this electron will come here. Okay. Now first we will run and after we will see clearly. After we'll see clearly. Now this is lone pair and this is a pi bond. Now here the delocalization of either lone pair or either a pi electron going to take place means there is a resonance effect or resonating structure. Now this lone pair comes to here and this pi bond comes to here. Now what will happen? Here is CH2 minus, this double bond, this electron moves here with CH2 bond, so CH2 minus, single bond CH, and here is double bond NH2 along with this is positive charge. This lone pair shift to here and forming a double bond. So we are going, we have draw the resonating structure of this compound. Okay, this compound going for the resonance due to conjugation, and we are going to draw the resonating structure of this as this. Now what rule number 3 said? Rule number 3 said that neutral species are stable as compared to charged species. Now as compared to our compound number 1 and our compound number 2, this is having a neutral species, no charge is there, but these are having a charge of minus as well as plus as well as. Now so as per rule number 3, the neutral species is more stable than charged species. So we can say that for stability order, first is more stable than second. Okay, because first is a neutral species and second is a charged species. Okay, so according to rule, neutral species is more stable than charged species. Okay, so this is rule number 3. Now we will come to rule number 4. What rule number 4 is say that negative charge particle are more electronegative item have more stable. Means if any of the atom which is electronegative and having a negative charge, that compound or chemical species is more stable. Okay, so negative charge on more electronegative item means more electronegative item having a more number of electron or a negative charge, then the compound is more stable. Clear? This is rule number 4. Let us take an example of this rule as this is CH2 double bond CH single bond O minus. Okay, now this chemical species doing having a resonating effect due to conjugation. How? This is pi electron, double bond means this is pi. Now here is sigma electron and again this is minus charge. So we can say that pi sigma and a electron means the condition of conjugation going to take place means pi sigma and electron. Here the resonance effect is going to take place due to conjugation. Now we are going to draw another resonating structure of this compound because this electron is going to delocalize in other atom. Okay, this electron is going to shift with this carbon atom. What will happen? First I will rough and I will show you how this delocalization of electron going to take place. Now what will happen? This electron is going to delocalize. It is shifted to here. It is shifted to here and it is shifted to here. This pi bond is shifted to CH2 bond. So we are going a second resonating structure as CH2 single bond, CH2 minus. This electron is shifted to here, so it will forming a single bond or sigma bond. This is CH, here is CH, and this minus electron is shifted to here, so it is forming a double bond. It is forming a double bond and this is O minus. Okay, so this is the second resonating. This is the resonating structure of this compound. Okay, this minus sign, this minus charge is shifted to here as this minus. Okay, so we can say that the delocalization of electron going to take place and resonating effect will be work. Okay, now according to rule number 4, we have to find out the negative charge on negative charge particle on more electronegative compound means it is more stable. Here the negative charge is with oxygen atom. Here the negative charge is with oxygen atom and here the negative charge is with carbon atom. And we know that the this both having a negative charge, and comparing with oxygen and carbon, this oxygen is more electronegative than carbon atom. Means electronegativity of oxygen is greater than carbon. So we can say that negative charge on more electronegative ions is more stable as compared to this. So we can say that this is compound number 1 and this is compound number 2, means this compound 1 is more stable than compound 2. Clear? This compound 1 is more stable than compound 2. Hello Aryan Taylor, clear? Oh, okay, we already cover rule number 1, 2, 3 and 4. Okay, we already cover 4 rules and we will apply these rules in our application part in the next slide. Okay, you have to remember only 5 rules of the resonating structure. Okay, this is rule number 4. Okay, now for rule number 5. Rule number 5 is very easy, that two close like charges. Two close like charge atoms are very unstable, very unstable. When any of the two like particles, any of the two close like charge atoms, if they are very close, they are very unstable. They are very unstable due to what? Due to repulsion. So we have take an example of this: A plus and A minus. Okay, and A plus, A minus, A plus. So these both are having 3 atom and 3 atom both having a charge, either positive or negative. Now if we compare this, the stability of compound this and stability of compound this, what rule number 5 say, that two close like charges are always unstable due to repulsion. So we can say that this having a plus charge, this having a plus charge, but here having a plus charge and here having a negative charge. So this compound number, this chemical species is more stable as compared to this, because there are two like charges close to each other. So we can say that the option number compound 2 is more stable than compound 1. Clear? Compound 2 is more stable than compound 1. Clear? Because here the two unlike charges are near. Here the two like charges are near. Okay, so we can say that this compound 2 is more stable than 1. Okay, so you have to remember 5 rules to find out the stability of resonating structure. Okay, we will. Okay, now we are going to give a brief recap about the rules of resonating structure. What we have studied in 5 rules, we are going to combine with a trick which is known as CCNNL. Okay, you have to remember CCNNL. Now, what rule number 1 say that? What rule number 1 say that? First you have to check what? You have to check the conjugation. You have to check the conjugation. In any of the chemical species, first preference will be always given to conjugation or aromaticity of compound. So this is the rule number 1. You have to check the conjugation. And what is conjugation? I already told the condition, 5 condition of conjugation. You can review that lecture number 3. Now, second rule is C. C means more the covalent bond. Higher will be the covalent bond, more will be the covalent bond, more will be the stability. So you have to find out the number of covalent bond, and the chemical species having more number of covalent bond, that is more stable. So rule number 2 says that more number of covalent bond means more the stability of what? More the stability of that chemical species. Okay, so this is rule number 1 and this is rule number 2. Now we will go for rule number 3. What rule number 3 says that any of the neutral species, any of the neutral chemical species is more stable as compared to charge. Okay, so neutral species is more stable as compared to charge species. Okay, so our rule number 3 said that the neutral species is more stable than charge species. Okay, now we will move further for our rule number 4. Rule number 1, 2, 3 and this is rule number 4. What our rule number 4 said that more will be the negative charge on any of the electronegative item, more will be the stability. Okay, so negative charge on any of the electronegative item, higher will be the stability. So negative charge on any of the electronegative item means that chemical species is more stable. Clear? So this is our rule number 4. Now we are going for rule number 5. SL means like charges always two like charges which are nearest to each other always repel each other and they are unstable. So like charges are always unstable. Okay. So we have to remember these 5 rules, C square, N square, L, and you can easily find out the stability of resonating structure. Clear? Shall we apply these rules to what? Shall we apply these rules to our concept? Okay. Now we will go for find out the stability order among following species. You have to find out the stability order between this and this. You have to find out which one is more stable and which one is least stable. Clear? So we will start with our concept trick or CCNNL. Okay. Always remember the rule which I have given to you. You have to apply on the basis of preference. First you have to apply this, after then this, and after that up to that. Okay. You have to apply this first. You do not apply to directly go to rule number 3. First you have to apply rule number 1. Then you have to check for rule number 2 and so on. Okay. So we will see first rule number 1 as conjugation. What rule number say that you have to check for conjugation or aromaticity of any of the compound. Now according to this, first we will check the condition of conjugation. Here the condition of conjugation is satisfied as compared to this and this. These both chemical species do not having any conjugation. Why? Here this is pi, here this is sigma, and here this is electron. Pi, sigma and electron. This is our condition for resonance or condition of conjugation. So we can say that this chemical species going for conjugation, so this is more stable as compared to 2 and 3. Okay. We will take as 2, this we will take as 3, and this is we will take as first. So first is more stable as compared to 2 and 3 because first species undergoes conjugation. We will write first species undergoes conjugation. So this satisfies rule number 1. So this chemical species is more stable as compared to this and this. So we will write stability order. Stability order as first we will write as 1. Now we have to compare the stability order among 2 and 3. You have to compare the stability order among 2 and 3. Now we will go for, this is failed here. Now we will go for rule number 2. Higher will be the covalent bond, more will be the covalent bond, more will be the stability. Now here is 3, 1, 2 and 3. Here will be the 3 covalent bond, and again here will be the 3 covalent bond. So rule number 2 is abolished. We will now go for rule number 2. Now we are going to move for rule number 3. What rule number 3 say that the negative neutral species is more stable as compared to charge. Here both are what? Here both are negative, both are charge particle, positive, negative, 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 and here the positive, negative, negative. So rule number 4 is also going to abolish. Okay. Rule number 3 also going to abolish. Okay. Now we are going for rule number 4. What rule number 4 says that? Rule number 4 says that this is important. Any of the electron or more electronegative item is more stable. Means the higher will be the negative charge on more electronegative item, more will be the stability. Now here is positive carbon having a positive charge and this carbon having a negative charge, or we can say that this oxygen atom having a negative charge and this oxygen atom has a positive charge. Means this chemical species is having a negative charge and this is having a negative charge. So we can say that this is more stable as compared to this. So we can say that stability of first is greater than 2 is greater than 3. Okay. This is more stable as compared to this and as compared to this. Clear? Now this according to these rule you can find out the stability order among all the species. Now we are going to start with the numericals of previous year. Okay, we are going to start the numericals of previous year. In the first previous year question, we have to find out the which of the following statement, which of the following is wrong about the resonance. We have to find out the which of the following is wrong about the resonance. Okay, these are the four statement you have to follow. Now, what is resonance? You can simply find out with this, and after that we will check each and every statement. Okay, here is the resonating structure of carbonate ion is there. Okay, so here is carbonate ion, again here is resonating structure of carbonate ion, and here is resonating structure of carbonate ion going to take place. Okay, these three are the resonating structure. Now we will go for one by one statement. Resonating structure have same energy and have same contribution. Yes, all these resonating structure having the same energy. Okay, energy will not be changed during the formation or intern conversion of these resonating structure, or we can say that this statement is true. Never energy will be changed during the formation of resonating structure. Okay, so this statement is true for this. Okay, now second statement, all resonating structure have same number of unpaired electron. Yes, according to this, due to the formation of this resonating structure, all are having same number of unpaired electron. The number of unpaired electron won't be changed during the formation of resonating structure. So we can say that this statement is also true. Clear? Now third, all resonating structure have same number of bond pair. No, this is wrong. All resonating structure have different number of bond pair, because here we can say that this is oxygen number 2. Here the bond pair is what? 2. Bond pair means the number of electron forming a bond. This is one electron, this is one electron, they are forming a bond, one bond pair. This is one bond pair. Here electron forming a bond means two bond pair. Means this oxygen atom having a two bond pair. But here this oxygen atom a one bond pair. Here is 2 and here is 1. So during the formation of resonating structure, the number of bond pair is going to change for each and every atom. So we can say that the all resonating structure have same number of bond pair. This statement is totally wrong. This statement is totally wrong, because during the formation of resonating structure, what going to take place? Bond pair of any of the atom is going to change. Here we can say that this is negative, this is 1, this is 1, but this is 2. Again here the number of bond pair is again changed for this oxygen atom. So we can say that during the formation of resonating structure, the number of bond pairs going to change. Clear? Now we will go for fourth option. All resonating structure have same number of net charge. Yes, all resonating structure have the same number of charge. No change of charge going to take place. Here we can say that this is having a -2 charge. Here we can say that this is again a -2 charge, and again this is a -2 charge. So during the formation of resonating structure, neither the energy change or neither the charge will be changed, and also the number of unpaired electron is also the same. Okay, so you have to remember that during the formation of resonating structure, unpaired electron, energy, and what amount of net charge is same in all the resonating structure. This thing you have to remember. During the formation of these during the formation of resonating structure, unpaired electron, energy, and C for charge never changes. Okay, so this statement is also true. Now we have to find out the which one having a wrong statement. So we can say that the wrong statement is statement number 3. Clear? So correct option is this question is answer number 3. Now we will move further. Give the resonating structure of the following compound. You have to give the resonating structure of the following compound. First, you have to check for either this chemical species or compound going for conjugation or not. If it give the condition of conjugation, the resonating structure will be drawn and resonance effect going to take place. Now, how we can draw? First we will check the what? First we will check the condition of resonance. This oxygen atom having a 2 lone pair. So we can draw as this 2 lone pair. Okay. So what is the condition of lone pair? Lone pair sigma double bond. Okay. double bond, sigma, lone pair. So here the properties of conjugation going to take place. Here the two properties of conjugation going to take place: lone pair, sigma, pi, or double bond, or we can say that second property is pi, sigma, pi. So these are the two properties of conjugation is going to take place. So we can say that this compound going for conjugation and giving a resonating structure. So we are going to draw a resonating structure of this compound as here. What will happen? This lone pair will move shifted to here. Okay, how it is going to shift it? This shifted to here and forming a pi bond. Again this shifted to here and this bond is shifted to this carbon atom. This is terminal carbon atom, you have to remember. Okay, so this is a terminal carbon atom and this double bond is shifted to this carbon atom and forming a resonating structure as first we will draw as this. Okay, here is what? Here is oxygen atom. This is having a one lone pair, and one lone pair is shifted to here and forming a double bond, and we are drawing a double bond. And again this double bond shifted to here. So now this double bond is shifted to here and we are drawing a double bond, and again this double bond is shifted to here. Means this consists of a negative charge. Okay, this consists of negative charge, and again this is a positive charge. Okay, so we will draw a resonating structure of this question, this chemical species. Okay, so by the rule of delocalization of pi electron, this is the resonating structure of this compound. Okay, so the correct option of this question is this same. This is double bond and this the bond is shifted to here, and this is negative charge and this is negative charge divided by here. We have to here to draw H also. Okay, this is H and this is H. Clear? So this is question number 2. Now we are moving to question number 3. Among the following least stable resonating structure you have to find out. You have to find out which one having a least resonating structure. Again we will go for our rule as CCNNL. Okay, this is our rule. First we will go for this, and after that we will move further as so on. Okay, first we will go for conjugation. We will go for conjugation. Here everywhere conjugation going to take place. Pi sigma negative charge. Here is pi sigma positive. Here is always in all 4 chemical species sigma pi sigma negative charge. In all chemical species conjugation is going to take place. Okay, so we will go for rule number 2. Okay, we will go for rule number 2 as C. You have to count the number of covalent bonds. So number of covalent bond we will count as 1 2 3 4 5 6 2 3 4 5 6 7 8. Again 8 1 2 3 4 5 6 7 8. Again 8 and this is again 8. Okay, all are having a 8 what covalent bond. So this rule number 2 is also we can't apply in this question. Now we will move further for rule number 3. Neutral species are more stable as compared to charged species. But here according to our question all are the charged species. So we can say that this rule is also nullified. This rule we can't apply. Okay. Now this is N. Now we will go for rule number 4. Rule number 4 say that negative charge on any of the more electronegative item that is more stable. So we are going to stable as this is more electronegative oxygen. This is negative charge. This is again a negative charge. This is again a negative charge, and this is again a negative charge. Clear? So all these having a negative charge. So we can find out the stability order with rule number 4. Now we will go for rule number 5. We will go for rule number 5 means like charges are always unstable. Two like charges which are very near to each other, they are more unstable. Now what will going to happen? This is a positive charge and this is a positive charge. This is more and least stable. They are least stable because two like charges cannot be each other. They are more unstable. They are less stable. They are more unstable. Okay. So this is less stable as compared to all. Here this is negative charge. Here this is positive charge. Here this is positive charge. Okay. This is stable. Now here is positive and here is negative, okay, here is negative, here is positive, okay. Now we will move further. Here is negative, here is positive, and here is negative, and positive is too far. So we can say that the least stable, we have to find out the least stable. So as per all question, this is the least stable chemical species because it consists of two like charges nearest to each other. Okay, so the correct option if this question is option number A. Okay, option number A is a correct option of this question. Okay, so you have to remember one thing, that you have to apply this rule as this from here. First you will give preference to this, after that this, and after that this and this. Okay, so you have to move from left to right, or rule number 1 to 5. Okay, now we will go for question number 4. Arrange the decreasing order of stability from the following resonating structure. Again you have to draw, you have to find out the stability order among all the chemical species. Now this is CH2 single bond CHO, this is the form of aldehyde and this is having a negative charge. We will write as CH2 minus, and here we can write as C double bond OH. This is having a aldehyde group. This is having a CHO minus double bond CH2. Again this is CHO minus single bond CH2 minus. Now according to all these chemical species, we have to find out the which one is more stable and which one is the less stable. So we will go for our trick as CCNNL. You have to go learn these 5 rules, or you can simply apply the stability order. Okay, now first we have to check for conjugation. Here the conjugation take place or not. Here is conjugation as pi sigma negative. So conjugation is going to take place in this option number A. Now we will go for conjugation in, we will see the conjugation in second chemical species. Here is pi, here is sigma, and here is negative charge. Means again here is conjugation is going to take place. Okay, now we will move further. Here is negative, here is sigma, here is pi bond. Means no conjugation going to take place. Means this chemical species is least stable. This is least stable as compared to this and this. Okay, so this chemical species is least stable because there is no conjugation is going to take place in this. Okay, so first we will say that third is least stable. Okay, now we will go for second, number of covalent bond. How we can found a number of covalent bond? Here is 2, 4, 2, 3, 4, 5, 6. Here is 6 number of covalent bond. Again here is 2, 3, 4, 5, 6. Again here is 6 number of covalent form. We have to find out the among first and second which one is more stable. Okay, so rule number 2 is not applied in this question because both are having a same number of covalent bond. So this rule is abolished. Now we will go for a charged species is more less stable as compared to neutral. So we can say that here again this is a charged species and this is again a charged species. So we can't go for rule number 3. Now we will go for rule number 4. Negative charge on any of the more electronegative item, that is more stable. So we can say that according to this, here is negative charge is with this carbon. Negative charge is with this carbon, but here the negative charge is with oxygen atom. And more than negative charge on any of the more electronegative item, that is more stable. Means we can say that this second is more stable as compared to first. So we can write the stability order as first, which one is more stable? This second is more stable because it consists of oxygen atom which is more electronegative and having a negative charge. Okay, so this is more stable. So we will give the preference as second, and after this is less stable first, and after that this is 3. So the correct option of this answer is 2, 1 and 3. 2, 1 and 3, and the correct option is option number A. Clear? So according to this trick, you can find out the stability order. You can find out the stability order of different resonating structure. Now we will move further for our question number 5. This is last question of our today's topic. You have to find out the order of stability among the following carbocation. What? You have to find out the stability order among the following carbocation. Clear? So again you can go for our trick as CCNNL. We will go for CCNNL. First we will go for conjugation. After that we will go for covalent bond. After we will go for neutral atom. And after we will go for negative charge on any of the more electronegative item that is more stable. And after we will go for like charges. Two like charges which are nearest to each other is more unstable, is very unstable. Okay, so we will start with the first trick, as we will see the aromaticity or the conjugation. Okay, now according to this first, second and third, which one having a more conjugation? So according to this, here the conjugation is going to take place because here is pi, here is sigma, and here is positive charge. So pi, sigma, positive charge. So here the conjugation is going to take place, means rule number first is applied. Now here we can say the conjugation, no conjugation is going to take place in chemical species second. Now we will go for rule number 3. Now we will go for chemical species 3, as here the pi, sigma and positive. Pi, sigma, positive. Pi, sigma, positive. Yes, here the conjugation is take place, and again the aromaticity play an important role in this compound. Generally the aromatic compound is more stable as compared to any of the other organic compound due to what? Due to its delocalization of pi electron. Okay, so this aromatic compound is more and more stable. Okay, so this is more stable as compared to 2, and no conjugation is going to take place. So we can say that second species is very unstable. So we can say that this is more stable, and this is this two, first and third are more stable as compared to second. So we will say that least stable is second. Now we have to compare the stability among first and third. Now we will go for second. We have to count the number of what? We have to count the number of covalent bond. But according to our first rule, it is having a conjugation again, and it is having a conjugation again. But I already told you in rule number 1 that aromatic compound is more stable as compared to another compound. So we will write the resonating structure, we will write the stability order as third is more stable, then first and then second. So the correct stability order is 3-1-2. So the 3-1-2 is the correct stability order among all these compounds. So you have to remember our 5 rule. This is our 5 rule. If you remember these 5 rule, you can simply find out the stability order of any of the resonating structure. Clear? So write the notes of my lecture, write all the rules and do the application part of previous year question of NEET and JEE. Okay, so next in the next class we will start with the mesomeric effect, and after we will move further for hyperconjugation. Okay, so till here, take care and thank you.